To start off Unit 4, we are going to do the Incline Lab. Now, the purpose of this lab is to investigate how the position of a car changes over time as it moves along an incline. So let's do a quick review. An object's displacement is its change in position. We can find this by taking the final position minus the initial position. Remember, this is a vector quantity, so we can have a positive or negative change in position, and the positive or negative simply tells us which direction the object is moving. Velocity is the rate at which the displacement changes. We can find this by taking the displacement divided by the time. In graph form, we use position time graphs to represent the motion. We put the time on the x-axis and we put position on the y-axis. A straight line means that the object is moving with a constant motion. In other words, it is covering the same distance every second. A negative slope means that the object is moving in the opposite direction. Look at the first part of the Incline Lab. You will need a long ramp, a blue or red dynamics cart, a motion sensor, your Chromebook, and a few textbooks. Once you have these materials, stack up to 6 textbooks at one end of the ramp so that it forms an incline. Place the car at the top of the ramp, making sure the wheels are secure in those grooves. Let it roll down the ramp. Be sure to catch it at the bottom. These cars are fairly delicate and they should not be crashing into anything. If you have not done so already, pause this video and go set this up. Number 3 in your procedure asks you to describe the motion of the car. How is this motion different from the book in the Balanced Forces Motion Lab? How does its position change over time? Is this a constant motion? We can probably say that the car is not moving with a constant motion. And what makes you think this is true? How could we provide evidence that the motion is not a constant? What do you think the position time graph would look like for this motion? Sketch a prediction on number 5 of your lab. In this lab, we're going to use a motion sensor to measure how the car changes in position over time. So here's a couple last-minute cautions. This lab is done on the floor. The cars are very rolly, so always place the car upside down so that it does not wander away. Also, one person is in charge of making sure the car does not crash onto the floor, into a wall, into a book, into a person, into anything at all. Be nice to them. This lab also really cannot be done properly with only one person. You need at least one partner with one person at each end of the ramp. One person to release the car and one person to catch it. Once you have everything set up, you will need to set up the graphical analysis app for this lab. Open it up and choose the sensor option. Plug the motion sensor into the USB port of your computer. You will get a screen that looks like this. The first thing that you want to do is to zero the force sensor. Hold your hand directly in front of the sensor and click on the button at the bottom right-hand corner. A menu will pop up and you will want to click the zero option. You should hear a few rapid clicks from the sensor, and if you hold your hand in the same place, the position will read 0. The second thing you want to do is customize the view. In the upper right-hand corner, click on the boxes and choose View One Graph. This will focus in on the position time graph and make it a lot easier to read. So now we should see this. To start collecting data, click on the Collect button. Now we tend to get better results if we click on it and then release the car rather than trying to do both at the same time. You should get a graph that looks something like this. Take a second and think about what this is showing us. The first part, where the line is flat on the x-axis, would indicate that the car is at the reference point, or in this case, the location where we held our hand when we zeroed the sensor. It also shows that the car is not moving. So this is where our car is at rest at the top before you release it. Now what about up here? A flat line on position time graph means the car is at rest. This would be the car at the end of the ramp after it has come to a stop. Now, neither of these parts is what we were interested in. The only part of the graph that we care about is the part where the car is moving down the ramp. So we are going to highlight this part. Click and drag your mouse so that the curved part of the graph is selected. It's okay if you have a little bit of those flat parts. Just remember that we're going to ignore that in our data. Once you're happy with your selection, click on the little magnifying glass in the bottom left corner. This will zoom in on the part you have selected, and you should see something like this. This part of the graph shows the motion of the car as it moves down the ramp. Take a screenshot of the zoomed in part of the graph. Paste this into a Google Doc and write a quick sentence about what kind of motion the graph is describing. This also might be a good time to give a name to your document so that you can find it again later. Calling it the Incline Lab would be a good way to go. So follow the instructions in the lab and create a position time graph for all 4 of these different motions. Paste all of these graphs into the same Google Doc, and this will be what you actually upload into the Google Classroom.